All right, now let's talk about solving logarithmic equations. And to solve logarithmic equations, we're just going to use the definition of a logarithm. All right, so what do I mean by that? So let's first express the equation in the form log base b of m equals c. The next step is going to be to write it in exponential form. This is where we use the BAP. All right, so log base b of m equals c is the same thing as base b raised to the c equals m. All right, and now we're going to solve for the variable once we're in that form. This is key, guys, and I'm going to say it twice just to make sure you guys listening to me hear me. Check the proposed solutions in the original equation. Okay, include in the solution set only values for which m is greater than 0, meaning whatever we get inside the logarithm has to be a positive number bigger than 0. Okay, and so you're gonna see where I do an example, check a couple answers, and one of them doesn't work because we get a negative number. All right, so number 4 is key. You've got to check your answers. All right, so let's look at an example. Log base 2 of x minus 4 equals 3. All right, well, what was our first step according to using the definition of the logarithm? Well, this is where we're going to raise both sides to the power of 2. All right, so raise each side to the power of 2 to undo the log. Okay, so now I have something I can actually solve. I can evaluate 2 cubed as 8, and then I can add 4 to both sides and get 12. I'm thinking 12 is my answer, but we do need to check it. So we plug 12 back into our original problem for x. All right, I get log base 2 of 12 minus 4, which gives me log base 2 of 8. Well, 8, that's just 2 cubed. So log base 2 of 2 to the third power simply gives me 3. All right, and so in fact, that indeed works. All right, 12 is our answer. All right, what about 4 times the natural log of 3x equals 8? Well, be careful. Our first step is not to use e. Our first step is to divide both sides by 4. So I get that natural logarithm, ln, by itself, so I have ln of 3x equals 2. Again, what was the first step? Divide both sides by 4. All right, so I have the natural log by itself. Now I use the e, all right? So I use e to undo the ln. So I have 3x equals e squared. All right, again, we have to apply it to both sides. And lastly, I can solve for x by dividing both sides by 3. So I have x equals e squared divided by 3. All right, let's check our answer. I plug e squared divided by 3 into my equation for x. All right, so the 3's will cancel inside the natural log. So I have 4 times the natural log of e squared. Well, the ln and the e undo each other, so I simply get a 2. And we have 4 times 2, which is 8, which is exactly what we're looking for. Okay, and so our solution set is indeed e squared divided by 3. All right, let's consider log x plus log of x minus 3 equals 1. I have 2 logs. Well, what can I do? Is there a way to combine those 2 logs into one logarithm? You betcha. We're going to use the multiplication property and bring the x in with the x minus 3 together using multiplication. So I have log of x times x minus 3 equals 1. All right, now I can use base 10 to undo the log. So I have 10 raised to the 1 equals x times x minus 3. All right, I just switched the sides, no big deal. If anybody's confused about that, just feel free to ask me. I just applied, if it were written in the same order as up here, we'd have x times x minus 3 equals 10. Okay, I just switched it around. All right, well, we're going to distribute the x. And what do we do from here, guys? We have an x squared. What does that mean? That means we have a quadratic equation, right? And we're probably going to have to use the quadratic formula. Well, I'm going to subtract 10 from both sides, and indeed I have a quadratic equation, and here I can use factoring or the quadratic formula. I'm going to use factoring, but again, we can use negative b plus or minus the square root of b squared minus 4ac all over 2a if you want. But again, I factored. I'm going to set each factor equal to 0 and solve for x. So I get x minus 5 equals 0, giving me x equals 5. X plus 2 equals 0, giving me x equals negative 2. Well, before I select that as my answer, I need to check both 5 and negative 2. All right, so we think we have two answers. Let's plug them back in and see. Let's check negative 2. I plug negative 2 in, and I get log of negative 2 plus log of negative 2 minus 3. Can we have log of a negative number? No, we can't. All right, so the number negative 2 does not check. The domain of a logarithmic function consists only of positive numbers. All right, so we've got to throw negative 2 out. Let's check 5. All right, so I plug 5 in. Log base 10 of 5 plus log of 5 minus 3 gives me log of 5 plus log of 2. All right, write that as one logarithm under multiplication. So I have log of 10. So now I have log base 10 of 10. What happens? They undo each other, and I get 1. All right, and so that is what we're looking for. And so our solution set is only 5.